This is the screencast for section 6.2, example 3. We're going to find an angle between any two vectors. There's a theorem that says if theta is the angle between the non-zero vectors u and v, then we can find that by saying the cosine of theta equals the dot product of the two vectors divided by the product of their two magnitudes. So in other words, the inverse cosine of the dot product of the two vectors over the product of the magnitude of the two vectors will help us find theta. Now that seems pretty far-fetched. I mean, how do they even get that? Did somebody just, stay up at night and go, poof, I've got it? Well, here's the theorem. So let's look at, it says we apply the law of cosines to the triangle determined by u, v, and v minus u. So here's u, here's v, and here's v minus u. Now if you remember, subtraction of vectors is a little bit different. We can look at this as u going the opposite direction, so negative u, and then adding on to it positive v, which then does create still that same vector. Law of cosines then says that the magnitude of v minus u, so this distance, squared is going to equal this distance squared plus this distance squared minus 2 times this distance times the cosine of theta from the law of cosines. Well, from property 2, we know that the magnitude of v minus u squared would then be the dot product of the difference of those two vectors. So in other words, if v minus u was one vector, the magnitude squared is the dot product of those two. So we then distribute out v minus u times v minus u, and we get the v squared, which is the magnitude of v squared, minus 2 times u times v, plus then the magnitude of u squared. Well, the magnitude of v squared plus the magnitude of u squared cancels out on the other side with the magnitude of u squared plus the magnitude of v squared. So I'm left with negative 2 u times dot product v equals negative 2 times the magnitude of u times the magnitude of v times the cosine of theta, divide both sides, and then take the inverse cosine of theta. Now that we understand that theorem, though, we can, given any two vectors, we can find the angle between them. So in part A of example 3, we're given the vectors u, which is 2, 3, and v, which is negative 2, 5. To be able to find the angle between them, I'm going to take the inverse cosine of the dot product of the two vectors divided by the product of the magnitude of the two vectors. So in the numerator, the dot product of the two vectors is multiplying the x-coordinates and then adding the product of the y-coordinates. And then the magnitude of each of the vectors is the square root of their x-coordinate squared plus their y-coordinate squared. And I get that angle is 55.5 degrees. Part B, to find theta, I'm going to do the same thing. The inverse cosine of, in the numerator, the dot product of the two vectors, and then in the denominator, product of the magnitude of the two vectors. Now after doing the dot products and finding the magnitudes, I started simplifying, and I found out that I'm actually trying to find the inverse cosine of negative square root 2 over 2. It's going to be 135 degrees. Plus 135 degrees is in the range of inverse cosine, so I could have just used my calculator. Then now try problem number 13, asks to find the angle between the vectors. So again, theta is going to equal the inverse cosine of the dot product of the two vectors in the numerator over the magnitude of the two vectors in the denominator, which I get to be about 115.6 degrees. And after drawing the picture, I can see that that is going to be an obtuse angle, and 115 degrees looks about right.